Hi, welcome to a calculator tutorial from Equaser. My name is Ahmed Shamshiri. In this video we are going to work with complex numbers using Texas Instruments TI-84 plus CE and TI-84 plus CE Python edition. This video is part of a full video of TI-84 plus CE. Link is below this video in the description. When you use complex numbers, this calculator can give us the conjugate of a complex expression. We can get the real part of expression. We can get the imaginary part of a complex expression. We can get the angle. We can get the magnitude of an expression. We can convert polar to rectangular, and we can convert rectangular to polar complex values. Let's set our calculators to default so we have the same settings. Second function, mem 7 2 2, enter. If you press some window or some other key that you're stuck, press second function quit to exit. Now for rectangular we use a plus bi, where a is the real value and bi is the imaginary. For example, in this case 3 is real value for this point and minus 4 is the imaginary. As you can see, this is actually the y-axis, but in terms of complex we call it imaginary. And for polar, in some books we use r theta as an angle, or we can use r e to the power theta I, where r is the magnitude, e is the Euler number as a base, and then theta is the angle, and I is the constant square root of minus 1. Now if we press mode and scroll down to this portion where it says real, this is a real number, and if I scroll down here on this side, that is rectangular complex, and if we scroll to the right, that is polar complex settings for this calculator. Let's set it to rectangular and press enter, clear to exit. And here on this screen you can see the setting is rectangular. Now the complex notation is such that in some books or teachers use a real plus a number with I, or you will see real plus j and an imaginary value. So I is at the end and here j is just before the number, or j, so remember, but this calculator uses I and we go with this I. And let's enter 8 plus 5i, 8 plus 5, and then second function I. For I am using this dot button. I is blue. All the keys that have blue values or the second function, when you press the button they will be activated. So 8 plus 5i and enter. And let's select the mode in polar mode and scroll down, go to polar, to the polar complex and enter. Highlight is selected, press clear to exit. And now let's enter 8 plus 5, second function I. As you can see, it has converted. The reason it's displayed in this format is the setting. So whatever value you enter, it will be displayed like this. Now if you want to enter 10 e to the power some value like this in polar format, we enter 10, second function e, this button here, and then the power is available now. Second function pi, and then alpha with fraction. The cursor moves down, 3 with the arrow go to the right, and then second function I. Now we have the expression. We can use it or we can simply press to see. Now you can see that it has been converted to 1.047 because pi has a value, and if you divide it by 3, that's the value you get. And this is the angle. If I do second function pi divided by 3, we are getting the same number, 1.047. Now let's go to classic mode. Using mode, at the top go to app and classic, enter clear. Now let's input this 10 alpha e. You will see that the power has now brought down with this parenthesis open, second function pi divided by 3, and I should put second function I and then close it. Now if I enter, of course we will see it like this. Let's go back to math print mode, up, enter, highlight, move to math print, clear. Now a simple expression, 2 plus 6i divided by 3i. So we have to put a parenthesis here, 2 plus 6, second function I, close it, divided by 3, second function I. So this portion does not have a real value. Let's divide it and we get the answer like this with magnitude and angle. Angle is 2.8 something. That's the angle in radian because the unit is in radian. Now if we go math and then scroll twice to the right, we see some operators with shortcuts. So we can select with arrow, go up and down, or we can press the corresponding shortcuts on the keyboard to go to that operator. Let's press clear. I'm going to explain it one by one, and the operators will be displayed at the top of the page. So now we are using conjugate. Let's say you want to find conjugate is conjugate of 2 plus 6i. So we press math once, twice, and then conjugate 1. It's opened, 2 plus 6, and then second function I. If you need to do some other operations, you need to close it. Otherwise, without closing, it will work. If I press enter, the value, the conjugate of the value is here represented with minus at the angle. Now, if we go to rectangular mode, and then scroll down here, press enter, clear, and let's enter it again. I'm not going to enter it. Let's paste it. I'm going to go up once, twice, highlight it, enter. Now the expression is available. Just press enter. You can see that it was 2 plus 6i. It converted to 2 minus I, and that is the conjugate of the previous expression. Now let's have a look at the saving complex values in variable memories. Now let's save 10e to the power pi over 3i into memory A. Let's bring this on the screen. A, we can insert a 10 second function e, and then second function pi. Now we have to bring fraction, second function, and then alpha 3, go with the arrow to the right, bring I, second function I, and after that we have to move the cursor to the right so it comes to the bottom, and here we can press STO, store, and alpha with any of these green letters. These are memories, so in this case I'm going to use A, so alpha, when I press alpha, A appears, and then A, that is, it says that save this value into A. When I press enter, it has been saved. The reason you see this in rectangular mode, because we have selected rectangular mode. Now let's recall memory A. Just press alpha and A, and if I press enter, it's available, but I can use with my calculation. Let's say we want to multiply by 5 or do some calculation. Now let's go to polar mode, and scroll down and select polar, enter, clear. Let's recall memory A, second function A, and enter. Now it's represented, instead of this format in rectangular, it's now in polar. Now let's get the real part of this expression. Mode, second function. For real, we press 2, and let's recall it because we don't have to type it already. We have the value, second function A, and the real part of that is, remember it was 5 plus some value in rectangular format, because and real part is 5. And imaginary part of 2 plus 6i, math, complex, 3, that is imaginary, 2 plus 6, second function, I, and enter. That's imaginary part of this expression. Imaginary part of 3, e to the power 5i, math, imaginary, and 3, second function, e, 4, second function, I, and enter. That's the imaginary part of this complex polar format. Now let's set the unit to degree, press mode, and degree is in here, once, twice, selected degree. Remember now it's radian. If I press enter, it has changed to degree, clear to exit. Now let's get the angle of 2 plus 6i, math, complex, 3, and then 2 plus 6, second function, I. And let's press math, 4, angle, 2 plus 6, second function, I, and the angle is 71.565 degree. Now let's set the unit to radian back, second function, go to radian. Radian is highlighted, enter, clear. Now it's in radian, and do the same thing, math, second function, go angle, 4, and let's recall the memory, second function, A, and enter, and in radian that's 1.47, and remember this was the angle, pi divided by 3, so we got the angle of A extracted if you need it in your calculations. And absolute value, ABS, is taking square root of square of real value plus squared value of imaginary. And let's say you want to get a magnitude of 7 plus 3i, press math, go to the complex and press 5, ABS or absolute. The bars are there, just enter the value, 7 plus 3i. And that is the absolute value. And for this, the same thing, second function, complex, 5, and recall it from memory because we have it in the memory, second function, A. And it was 10 to the something, so that is the magnitude. And this is what I did. Now we want to get a value converted to rectangular, rect. Now let's bring this value first. Now alpha A, bring the value, and then math 6. This says get this value, whatever value, either from memory or direct print, convert it to rectangular. So we got 5 plus 866 I. That is rectangular format. If you want to get the polar, same thing, 7 plus 3 I, and we want to bring it, convert it to polar, regardless of the setting. Remember, this was showing that polar, it was showing rectangular, because when you use these operators, it converts it directly. So math, complex, 7, that's polar, and you will get the polar format of this value. So this was all features of this calculator for complex calculations. Thanks for watching. Please thumb up the video, and also please don't forget to subscribe.